Hey, so in this video, we're going to look at the following problem. The problem is when planning a party, you want to know whom to invite. Among the people you would like to invite are three touchy friends. You know that if Jasmine attends, she'll become unhappy if Samir is there. Samir will attend only if Kanti will be there, and Kanti will not attend unless Jasmine also does. Which combinations of these three friends can you invite so as not to make someone happy? Now, one of the things that we did in the lecture was to take some of this text that's given in a problem and find the appropriate propositional variables. So what we're going to do now is we're going to assign three propositional variables. We're going to use lowercase j, lowercase s, and lowercase k here, where lowercase j stands for Jasmine, Samir, s for Samir, and k for Kanti. Okay, so now that we have these propositional variables, the next step is to find the appropriate relationship between these propositional variables that may be suitable for this question here. I'm just going to close my office doors to get the noise eliminated. Okay, so let's look at the appropriate relationship that may exist here. So the question tells us that you know that if Jasmine attends, she will become unhappy if Samir is there. And what you're trying to do is we want to invite people on in this party such that nobody's unhappy. So if Jasmine attends, it's obvious that Samir should not be present. If Jasmine, then no Samir. We don't want Samir to be present because Jasmine is going to be unhappy, right? So this sentence in pink over here will translate into propositional logic. If Jasmine, then no Samir. Samir will attend only if Kanti will be there. So the connection between Samir and Kanti is such that if Samir attends, then Kanti will be there. Okay, so this is the connection between Samir and Kanti. If Samir, then Kanti. And finally, I have over here, and Kanti will not attend unless Jasmine also does. And Kanti will not attend unless Jasmine also does. Okay, so first thing, when we see the word unless can also be translated into an inclusive or, which means that the relationship between Kanti and Jasmine is such that Kanti will not attend, meaning no Kanti, unless, translates to or, Jasmine also does, or Jaya. Okay, so I've got my three relationships between my propositional logic, and now all I have to do is I have to make sure that this 1, 2, and 3, what is the appropriate value? What is the appropriate value that the propositional variable can take on? Meaning, what are the appropriate truth value that J, S, and K can take on such that 1 and 2 and 3 are all going to result in true, right? We want to make sure that that 1, 2, and 3 are completely satisfied. And if I can figure out the appropriate values for G, S, and K, then I know which of the appropriate combination can be chosen and which of these people can be invited to the party. So let's kind of take a longer approach. So it also gives us a good practice at looking at truth tables. So I've got three propositional variables here, which means that 2 to the power 3 gives you total of 8 possible values in the permutation space. So if I look at J, S, and K, okay, so this is 0, 0, 0, 0, 1, 1, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 1, 0, 1, 0, 1, 0, 1. So I've got my 8 possible values for J, S, and K. The first one is if J, then not S. So let's also get not S here, which is 1, 1, 0, 0, 1, 1, 0, 0. And then finally, I'm looking at if J, then not S. And I'm looking at column 1 and column 4 here, which will mean this is going to become 1 1 1 1 1 1 0 0. And then looking at if s then k, so this piece over here, if s then k, which is these two columns over here. So I'm looking at 0 0, which makes it 1 0 1 makes it 1 1 0 makes it 0 1 1 makes it 1 0 0 makes it 1 0 1 makes it 1 1 0 makes it 0 1 1 makes it 1. Okay, and then finally I've got not k here, so let's get not k, so that becomes 1 0 1 0 1 0 1 0, and this is not k or j. Okay, so what is not k or j here? Not k is this piece here, j is over here, so I'm looking at this column and this column, I'm doing an OR between them. So 0 and 1 gives you 1, 0 and 0 gives you 0, 0 and 1 gives you 1, 0 and 0 gives you 0, 1 and 1 gives you 1, 1, 1, and 1. Okay, and then finally I want to get an AND. I want to get an AND between all of these three guys, which means the only now that the truth table is completed, let's look at this column over here, okay, which expresses the first relationship between J and S. The second one is over here, and the third one is over here. And all I'm going to do within these three columns is look for those rows where I see a 1 in each one of these boxes. So the first row over here, 1, I've got a 1 here, and I've got a 1 over here, which means don't invite Jasmine, don't invite Samir, and don't invite Kanti. And which makes sense, because if I don't invite three of them, none of them will be unhappy, right? But my party is going to be boring if nobody comes to my party. So this is a valid assignment, but I'm going to choose the one that at least I can invite one person, at least invite one or possibly more than one person to my party. Okay, so this could be one assignment over here. Let's look at some other some other rows where I can see every single row being equal to 1. So now if I look at, let's say, Jasmine being 1, Samir being 0, and Kanti being 0, which happens to be this row here, 1 1 and 1. Okay, this tells you that one other option could be I just invite Jasmine by herself, but I do not invite Samir and I do not invite Kanti. And this would also make sure that nobody will be unhappy in my party. Okay, and there's one more option where I can invite Jasmine and Kanti. So if I look at Jasmine, which is over here, 1, and Kanti 1, okay, which is the next row, just immediate next row, which is 1 over here, there's another 1 over here, and there's another 1 over here. Okay, so the other option could be I invite Jasmine, and I invite Kanti, but I do not invite Samir to the party. And this would also mean that I can have at least 2 people attending my party, and nobody would be unhappy in my party. Okay, so I hope these YouTube videos help. I hope it gives you a good practice into some of the problems that we're looking in the lecture. And again, I'm more than happy to make more of these if you like me to do them.